Hi class, now we're going to learn about vector addition. So just a reminder that a vector is something that has both magnitude and direction. So for instance, saying that Kingsville is 15 kilometers away doesn't offer a lot of information. That gives us a scalar quantity, a distance. But giving a distance and a direction, so 15 kilometers east, for instance, gives a lot more information. So that's why vectors are needed. Okay, I'm going to start with just showing an example of where vector addition would be used. So something like this. Two tugboats are towing a cargo ship as shown below. Tugboat A exerts 15,000 newtons of force at a 30-degree angle while the tugboat B exerts a force of 20,000 newtons at a 50-degree angle. Determine the magnitude and the direction of the resultant force acting on the cargo ship. So in other words, where is this cargo ship actually going to go? I mean, it has to do with the fact that these two can be represented by vectors. Okay, boat B would be represented by a longer vector because it is exerting more force. Boat A would be represented by a shorter vector because it is exerting less force. So the resultant will go somewhere between these two, but more angled towards the longer vector. So you can see here it's worked out. There's different approaches to how we can actually solve where this tugboat is going to go. But eventually you can get to this solid blue line, or this dark blue line. That's where it will go. So visually here, I'll put the link to this applet that you can play around with. So if you have two vectors, you'll see this one's longer, this one's shorter. What would be the sum of these two vectors? Well, I can just click show sum and it will make it for me. Okay, so notice that it's more in this direction than this because this one's longer. But how can we actually find this? Well, there's two ways. One way is to take the two vectors and put them tail to tail. If you made a parallelogram out of those two vectors, so it continued them here and here, the sum of the two vectors is actually the diagonal of the parallelogram that you can create. So one way of finding the sum, the additional, the resultant vector, is by creating a parallelogram and finding its diagonal. Okay? Another way of doing it is if you take these two vectors and change them so that they are head to tail, like this, then the resultant vector is the one that will complete a triangle. And this is called the triangle law of addition. So we'll be learning about both of these in this video. So you can see as we change this, it will change the resultant, right? If we make it shorter, then now this vector has more power of where it's going to go. Okay, so how you change these two vectors has a great impact. Okay, so let's get to the note. Okay, so adding two vectors results in a single vector, which we call the resultant vector. So first we're going to do the parallelogram law. So if you are given two vectors A and B, they can be placed tail to tail, as shown in this diagram here. So then you want to construct a parallelogram, and the resultant vector is the diagonal, okay, of this. So I will show you how we construct it. So you take, this is your theta, so the angle between the two, okay, and then you create a parallelogram. So this vector here would be equal to A, and this vector here would be equal to B. So you can really call them the same thing. Okay, we can also, just for notational purposes, put capital letters on all of these, heads and tails, just so we can talk about this. So now the diagonal AD is the resultant vector. So I'll take a different color here. So the addition of A plus B, oh, this is going to be terrible. You guys use a ruler. This is the resultant vector, A plus B, this green guy. Okay, so later on when we do some examples, you'll see that we're going to use the cosine law to find this, using the fact that, okay, if you continue this as a straight line, because these two lines are parallel, AC and AD are parallel, this angle here would be theta. So this angle on the inside is 180 degrees minus theta. And that is important to label that angle that way so that later on we can use the cosine law. Okay. So there are 4 important points to note. So the magnitude of the resultant is always less than or equal to the magnitudes of A and B. Okay, so what does that mean? It means that if you have A plus B, so that is the magnitude of the resultant, it has to be less than or equal to if you just took the magnitude of A and you added it to just the magnitude of B. So what has to be true for these statements to be equal? Well, if A and B are in the same direction, then the resultant will equal the sum of the resultant, the magnitude of the resultant will be the same as the sum of the 2 individuals. So if you have A and B going in the same direction, like that, then their resultant, A plus B, is just the sum of their individual magnitudes. Okay? But if they are opposite directions, so let's say you have A and then you have B in the exact opposite direction, okay, then the resultant will be this difference of their magnitude. So this would be A plus B. All right, now there is something called the zero vector. Okay, so for example, if we have a vector like this and a vector like this, let's call this AB and let's call this CD. So in this case, AB plus CD would equal the zero vector because you get back to start. Okay, we can also say that AB plus a negative BA would give us the zero vector. We can also say that AB minus AB gives us the zero vector. What's important here is that you notice in all 3 cases, because we are adding vectors, our resultant has to be a vector. Okay, it's really tempting, especially with this last example, to just write 0 without the vector symbol on top of it. But that just would represent a magnitude or a scalar, which doesn't make sense. So a zero vector actually has a magnitude of 0. It is very important that you don't say it has no magnitude. I hear that all the time. That's not true. It does have a magnitude of 0, which is different than having no magnitude. So make sure that that is understood. And then there is no direction for the zero vector. Okay. Now we'll get into the triangle law of addition. So this can be used instead of the parallelogram law. It's important to understand both laws because we will be using them in different applications. So I know physics students are more comfortable with the triangle law, but you do need to learn the parallelogram law as well. So in this law, you would take the tail of B and stick it onto the head of A. So notice here, this is where you place it head to tail. Okay, and then the resultant goes from the tail of A to the head of B. So this vector here is A plus B. Okay, now you can also label this Q and R and S. So it makes sense that QR, vector QR plus vector RS equals vector QS. Because I always think about it, well, if you're going from Q to R and then R to S, that's the same thing as going from Q to S. So that's a way that I remember it. Okay. So how do you actually do the difference between 2 vectors? So what about if you're subtracting 2 vectors? Well, I would say that the simplest way to do this is just to redraw B as its opposite and then add as before. So if you're saying that this is vector A and this is vector B, just draw negative B and now add A plus the opposite of B, right? Because that's the same as A subtract B. So in this case, you would have your A and then your negative B. Sorry, that's supposed to be horizontal. And then your resultant vector would be here. So this is A plus negative B with the vector signs. Okay, so just remember that A plus negative B is the same thing as A minus B. This way, really all you're learning is addition, and you know how opposite vectors work. So you're not really learning like a new rule. You're just kind of changing it to addition. The other way of doing it, which is in my mind more complicated, is that you can arrange them tail to tail. Okay, so you can put A here and then B here. So leave it as it was. I made that one too long. And you kind of have to think, what vector do you add to B to get to A, which would be here. Okay, so you think, well, B plus A minus B gets me to A. So it's kind of like having to undo some thinking. So it's a little bit more complicated. I recommend option 1. Okay, so here's our first example. We have two vectors, vectors A and B, and we're given their magnitude. So this means that A is 3 long and B is 2 long, and the angle between the two vectors is 60 degrees. So let's draw that. So here is, we'll say that that's 3. And then 60 degrees is about like this, right? Ish. And then B is slightly shorter at 2. So what is the vector, or what is the magnitude of A plus B? So I'm going to create this parallelogram here, knowing that this is 60 degrees. And I'm going to draw the resultant vector, which is the diagonal of this parallelogram. So because this is 60, that means this angle is 120. So again, either using the C pattern or the pattern I described earlier. But this is just 180 minus 60, right? So then how big is this line A plus B? So we're going to use the cosine law because we know that this is 3 and we know that this is 2 and we know that the angle is 120, so we can use the cosine law. So you're like, Mrs. Weens, what is the cosine law? Well, don't worry, I will remind you right now. So the magnitude of A plus B squared is equal to the magnitude of A squared plus the magnitude of B squared minus 2 magnitude of A, magnitude of B, cos 120 degrees. Okay, so it's always like C squared equals A squared plus B squared minus 2AB cos C is the cosine law. Okay, so we'll put in the magnitude of A is 3. So 3 squared plus 2 squared minus 3 times 2, and then cos 120. Okay, so you put that in, you get your square root. Okay, you guys know how to use a calculator by now. So then you square root it and you get root 19 as an exact value. So that is the magnitude of the resultant vector. Now it wants us to determine the direction of A plus B relative to A. So to do that, we want to find this angle here, theta. Okay, so for that, we can use the sine law. So sine of theta, okay, over its opposite, so 2, equals sine of 120 degrees over root 19, okay? So the sine law is sine theta over its opposite side equals sine of something we know over its opposite side, and this is the ratio that we know. So you can rearrange and solve for theta, and you get 23.4 degrees. So therefore, we can say actually that just should say A plus B with no magnitude. Sorry, these magnitude lines shouldn't be there. So A plus B is 23.4 degrees toward B from A. Okay, so you have to give some description. It said relative to A, so I did it in that way. Okay, you have to give it some kind of reference point. All right, example 2. Suppose you are given these vectors A, B, and C as shown below. Using these 3 vectors, sketch A minus B plus C. Okay, so you recopy A, and then you want to go minus B, so I draw the opposite of B. Okay, and before I do anything else, I'm going to draw the resultant vector of those two. So here is A minus B. So now I'm going to think about, okay, what about A minus B plus C? So I'm going to add C onto this guy, okay? So then I put C up here. And now my final resultant vector is A minus B, which is this guy, plus C. So I draw the triangle from there to there. So that guy is A minus B plus C. Okay, last example for this video. Oh, sorry, no, 2 more. Okay, in the rectangular box shown below, OA is vector A, so let's label that as little a. OC is B, so that's little b in there. And OD is C, so there's little c there. Okay, so they want us to express each of these in terms of A, B, and C. So either as opposite vectors or the addition of vectors. So we can see that OA and BC have the same magnitude, but vector BC would go, oh, sorry, and I should draw arrows on these. But vector BC goes in the opposite direction of OA, so BE is the same as negative A. Now we get to GF. So GF is the same magnitude as OA, and it's in the same direction, so we can just say that it is equal to A. Now, OB goes from here to here. So that is the diagonal of the parallelogram created by A and B. So we can say that OB is A plus B. AC is here to here. So that would be the parallelogram created by A and, B minus A. This always confuses me. Okay, so if we think about a triangle, what triangle would AC connect? Okay, so if you put B to the other side, going the other way, and then you add A to it, you would get that, or you can think about it as A minus B. So I just think of the triangle law there, where you have to have B going in the other direction. Then we have B to G. Okay, so B to G would be the same as, well, here's A plus B to G would equal negative C. So that's the same thing as if you have negative C plus A equals BG. So negative C plus A, or you could have A minus C. Okay, now what about OF? OF goes right through the entire rectangular box. So that would be the addition actually of OB plus C. Okay, so think about this. This would be as if you had OB plus C. But OB can be rewritten as A plus B. So really, OF is A plus B plus C. Okay. One more, and the proof will be done in a separate video for tomorrow. So an airplane heads due south at 300 kilometers an hour. So we can represent that with a very straight vector. Okay, so we'll call that A for the airplane. And we'll say it's 3 long if you want to use a ruler. And the wind comes from the west at 100 kilometers per hour. So I could draw it here, but I want to use the triangle law. So I'm going to have the wind being right here. What is the resultant velocity of the airplane? So relative to the ground. So the actual airplane will be going here because it will be the addition of the airplane plus the wind. Okay, so notice that it asks for velocity, which is speed plus direction. So we need to find the magnitude of A plus W, and we also need to find the size of that angle there. Okay, so A plus W, we can actually use Pythagorean theorem here because this is a right angle triangle. So we can use the square root of the magnitude of A all squared plus the magnitude of the wind all squared. So this gives us 316.23 kilometers per hour. So it makes sense that it's faster than the plane is going because it's getting some extra speed from the wind. Okay, so now we can use tan theta, which is opposite, so 100 over adjacent, which is 300, to get that theta is equal to 18.4 degrees. So think about it, that's going south 18.4 degrees east. So the velocity of this airplane is 316.23 kilometers per hour, going in a direction of south 18.4 degrees east. So there is some vector addition in a real world problem. So hope you guys learned a lot about vector addition. Thanks for watching. Hope you learned lots.